Hello everybody, welcome back to Embetronics. This is a part of the Bootloader series where we are going to discuss the firmware update using the SD card. In our last tutorial, we have tried updating the firmware over the air using Bluetooth Low Energy. Then, I have got a request from the user to add the firmware update using the SD card. That's a good idea, isn't it? So, I have created this tutorial. I have the SD card breakout board with SPI communication. I have followed this tutorial to interface the SD card with the STM32 using STM32Cube IDE. The link to this website is available in the description. Let's move to the Bootloader 0.3 source code and we will add this feature on top of that. Then click the bootloader.ioc file. Go to middleware and click FATFS. Select the user defined. Let's enable the use LFN, which will allow us to use the long file name. I am going to use SPI1 for the communication. So enable the SPI1 as a full duplex master. Set the data size to 8 bits. Prescaler to 128. See here, PA5, PA6 and PA7 are used for this SPI1. We need to have a chip select pin. I will use PD14 as a chip select pin. So, set that as a GPIO output. For better understanding, we will rename this PD14 GPIO as STCS. We have configured. Let's save and generate the code. It has generated two directories called FATFS and middlewares. Create a new C file in FATFS target. Let's name it as a user-diskio spi.c. Copy the code from our GitHub. And paste it to that file. And create a header file called as user-diskio spi.h. Copy the header file content from the GitHub and paste it here. Then we will follow this guide. Copy this line to user-diskio.c. Let's map these user-diskio function calls to our user-diskio SPI functions. Copy this line to the main.h. Please note that you have to place your code between user code begin and user code end. If you place it randomly, then it will mess up your code when you regenerate your code. We are using SPI1. Then replace this code in user-diskio spi.c. That's all. We have set up our SD card with the STM32. Here they have told us how to use the SD card file system. I have written a new function and let's copy that to our etxota update.c. Include the FATFS header file. I am copying the code from our Git repository only. Please check out the Git repo using the link which is available in the description. Copy this macro and add it to the etxota update.h. Also, add these SD card exception codes. Finally, add this function declaration. Let's build the code. Okay, we are error free now. I will explain you the logic that I have implemented. When we call this function, we mount the SD card. If there is no SD card, then we will not process further and return immediately. Then we are opening the file called app.bin under the etx_fw folder of the SD card. So, we have to place our firmware image under the etx_fw folder and rename it to app.bin. If we don't find such a file, then we assume that no firmware update needs to be done. So, we break here. If the firmware file is available, then we are getting the slot number to update. Then, we get the slot information and make that slot as invalid as we are going to update the slot. After that, write the updated slot information to the flash. Then, we are reading the data from the file chunk by chunk. The chunk size is 1024 bytes. First, clear the buffer. Then, we read the chunk data from the SD card file and write it to the flash memory. This function has been used in our OTA update also. So, I am reusing this function here. It will keep on writing the data to the flash from the SD card until it flashes complete firmware. We have to calculate the CRC for this. Then update the slot information like CRC, firmware size and etc. Then write the updated slot information to the flash. After that, we close this file. Finally, we will delete this firmware file from the SD card. Then, we are unmounting the SD card. We can call this function from the main function. Before that, I will increment the bootloader version to 0.4. Call that function that we have created. If you see this function, it may return etx_sd_ex no SD when no SD card is available. etx_sd_ex_fu error when there is an error in the firmware update. etx_sd_ex error when there is an error before we start the firmware update, and etx_sd_ex OK if we successfully updated the firmware from the SD card. If we return this, then no need to check other mediums for firmware updates. We can skip that. First, let me copy the code from Git. I will replace this part. Don't get confused. I will explain now. Now you see the return value of the check update firmware SD card is stored into the SDEX. If there is a firmware update error, then we will not process anything and stay here. If it is etx_sd_ex OK, that means we have updated the firmware from the SD card and no need to check for other sources for firmware updates like PC tool, BLE. So we will skip those part and directly we load the new application. If there is no SD card present or the firmware file is not available, then we will check other resources for firmware updates. Based on that, we will start the firmware download process. Before we see the demo, let's see the connection diagram of SD card and STM32. SD card is connected to the SPI1 and chip select is connected to the PD14. Okay, let's build it now. Flash the code. I am opening the serial terminal. See here, Bootloader 0.4 is running. SD card mounted successfully. No firmware was found in the SD card. And booting normally. Now I will copy the firmware to the SD card. Insert the SD card into the laptop. In the ETX firmware folder, no firmware is present. I will just copy the Blinky bin 0.4. Now rename it to the app.bin. Eject it and insert it into the SD card breakout board. Clear the logs. Then press the reset button. See, firmware found in the SD card. Slot 0 is available and erasing it. Now it is running application 0.4, which blinks the blue LED in 2 seconds intervals. That's all I have got today. If you are directly coming here, then you might be confused. I request you to go through the previous parts of the Bootloader series. Check the description for links that I have mentioned in this tutorial. Let's discuss some interesting things in our next tutorial. Thanks for watching. See you soon.